intelligence within that. So if you see, we are making a machine to learn. The machine is learning in three different ways. The first one is the supervised learning, where we are training the machine with a proper label, so it is identifying the object. And the second one, it is all about unsupervised learning. The machine itself, it is picking up the similarity in the object, it is clustering together, and it is identifying the object or classifying the object. That is unsupervised learning. The third one, what we are talking about, is reinforcement learning. In reinforcement learning, a robot, for example, we cannot give an algorithm. We cannot tell step by step what it has to be done. We can say what is right, what is wrong. Only the rules are programmed. So from environment it is learning, from experience it is learning, and a robot is acting. So that is the best example what I can say for reinforcement learning. So reinforcement learning is closely related to IoT. So again, the IoT, the Internet technology devices, the machines and tools that are connected by Internet through wireless technologies. So Internet of Objects, it refers to wireless network between the objects. So the unification of technology, the integration of all technologies as a low-powered embedded systems and cloud computing, big data, machine learning and networking. This all contribute to our IoT. So we are going to see today how IoT is playing a major role in big data, and also it is contributing to machine learning. Okay. So in 1990s, we had only 100 million devices connected to Internet. Now, if you see in 2000, slowly it was growing, and now in 2020, tens of billions, that is approximately 50 billion devices are connected to Internet. You can see the graph. As the year grows, the number of devices that are connected with the Internet is also growing. So we have a wide scope in IoT. So the new dimension of IoT, if we see, anytime connection. I think most of us, especially during the pandemic, we would have got hurdle-free, a seamless Wi-Fi connection at our home. So all our devices, smart devices, say for example Alexa, it is all connected 24/7 with Internet. So anytime we can access. That is the on-the-move devices, outdoor or indoor, nighttime, daytime, we are connecting. Second, anything connection. Any device, smart device, it could be connected. It could be human to human we are connecting, or human to things, or things to things. It is all connected. Then third is any place connection. If we just have Internet, it is enough. You would have heard about the automated car, the unmanned vehicles, Tesla. There also IoT is predominantly using excessive, the sensors and the actuators which are connected to Internet. All the signals it is receiving, whether it can be a voice recognition, it can be a language recognition, it could be an obstacle recognition, it could be a light recognition, it could be signal recognition, or it could be a pitfall recognition, a humidity recognition. Everything in a car is automated using the sensors and actuators that are connected to Internet. So from any time, any place, any device which is connected, it is the major contribution of IoT, I would say. So the first application we can say, the dynamic control of industry and daily life. That is the reason we have IoT. It is resource efficiency, it is improved, and energy conservation. That is also saved a lot. We are going to see a case study how this energy conservation is happening with the help of big data and IoT. Second, improve the resource utilization ratio. That means any device which is we want to access it, so it is connected to Internet, or the data you want to retrieve it, which is in the remote server or it is in the cloud-based application, anywhere the data could be accessed and it could be used. And then the technology integrator. So nowadays we have this inclusive technologies, whether it is a mechanical engineering discipline, or it is electrical or electronics, or it could be IT and computers. Everything is linked together. So the technologies are all integrated if we want to work in future. Earlier the disciplines were distinct. Now it is all interrelated. Even IoT, we are using multiple integrated technologies. The relationship between the human and nature, that is also one of the contribution of IoT. One best example I'll tell you, in Japan, they were harvesting cucumber. Okay, and many times you know that cucumber, if 1 or 2 days, if the days after ripe you are harvesting, it is into tremendous loss. So every year around 40% of loss they were incurring because they were not able to identify the correct time and the period for harvesting. Later, they used image recognition and deep learning technology. They installed the cameras everywhere in the field, I would say, and they had given what is the correct shape or what is the correct features of a ripe cucumber. So that was trained to the machine learning system using deep learning network, and whichever plant it has lot of cucumber which are ripe to be harvested, the machine used to blink the lights there. They were identified by different colored lights. So that lights were connected to the circuit which were monitoring which plant, which number, where you have to harvest. So this is the kind, that is what human and nature. So nature is producing all, plants or vegetables, or I can say fruits, and it is connected through the technology to human, and they could save at least 30% of their losses because of the deep learning technology and image recognition. With the help of IoT, they were able to save their money, I would say. That is the example for human connected with nature. A lot of pollution and disaster avoidance we can do. How we know that the GHG gases, that is the greenhouse gases, which are very much affecting the carbon emissions. I think a lot of environmentalists and even IPCC, Interpanel for Climate Change, every year they are warning us. But thanks to pandemic, the air pollution level has drastically come down during that time because of the number of vehicles the movement are being restricted, and the emissions have been reduced. Otherwise, the ozone layer was becoming thinner and thinner. So this smoke detector we have, and then what are the gases in the greenhouse gases which are emitting more carbons, those levels, it is all monitored and it could be controlled. The alarming situations, the alarm, it was all shown using IoT. The sensors are contributing a major way, so we could avoid the pollution and disasters. So in every field, if you take, IoT has a major contribution. Now, let us come to big data. So how IoT is connected with big data? So for that, first we will understand what is big data. From the name itself, it is very big. Is it a buzzword? Is it a bubble? Is it a gold rush? Gold rush, I think you all know the term. In earlier days, after Second World War, wherever the gold mines the people find out, they used to migrate from one location to another location. So whenever the mines are found, the people automatically relocate to that particular place. The same thing here. The revolution, is it happening? Is it all contributing to big data? Better, let us see what Early says. He says everybody talks about big data, but nobody really knows how to do it. Everyone thinks everyone else is doing it, but everyone claims they are doing it. Of course, this is a vague definition. This was the standard in 2013. But later, if you can see, after the invent of this Google file systems or Hadoop architecture, big data has completely taken a big evolution, I would say. So, we can say, the consultants say there are 3 quintillion bytes of data are created every day. 3 quintillion. 1 quintillion is 1000 power 6. You can imagine what kind of data it is being created every day. It comes from everywhere. It knows all. It is coming from everywhere. According to the book of Wikipedia, its name is big data. That means the data which is generated every day in quintillion. It can be from Internet of Things, it can be from social media, or it can be from other domains. We will see who are the major contributors of big data. So big data, some people feel that it lives in the cloud. It knows what we do. Right. So normally we are familiar with the term bits and bytes. Right. And 1024 kilobytes, we have 1 megabyte. 1024 megabytes, we have gigabytes. 1024 gigabytes, we have 1 terabyte. Terabyte is 10 power 12. If it is 10 power 15, it is petabyte. If it is 10 power 18, it is exabyte. If it is 10 power 21, it is zettabyte. If it is 10 power 24, it is yottabyte. If it is 10 power 27, it is brontobyte. You see, we are living in the era of brontobyte because majority of the data, it is coming from the sensors, that is the data from IoT. So I would say IoT are the first major contributors for big data. If the volume of data is reaching in brontobyte, it is only due to IoT and social media. So just be familiar with the terms zettabytes, yottabytes and brontobytes. I just put this slide. Now let us see the evolution of big data. If you see, initially it was all telephone, and then from telephone the evolution happened. So migrated to mobile, similarly from desktop now to cloud, and from car to smart cars, autonomous vehicles, which we discussed. Now, the second major contributor is IoT, Internet of Things. So 50 billion devices are connected to Internet in 2020. And apart from this, the major other contributors, other domain, I would say cargo container, energy substation, smartphones, wearable devices, even the animals, they are all connected with the RFID tags for the location purpose, reading purpose. Even we have shopping carts, vehicles, bikes, e-bikes, smart meters, spotlights, parking meters, and other sensors, cameras, oil barrels, and buildings. Everything, the turbine, wind turbine, gas pump, all these things are connected to Internet and producing dynamic data. So in a day we see we are getting terabytes of data, not terabytes, it is yottabytes of data. We are going to see that in 1 minute how much data is being produced from various sources. So we can say sensors, smart objects, devices, all clustered systems. They are all rapidly adopted digital infrastructure. So it is 5x faster. It is 5 times faster than the electricity and telephony. So IoT works 5 times faster than the electricity and telephonic technology, I would say. Now the third is social media. Social media is a major contributor for big data. Am I audible, sir? Is it clear? Can I get a confirmation from the audience?
Yes, ma'am, you are audible properly.
Thank you. Thank you so much.
Thank you.
So, lot of Instagram pictures are being posted and lot of Facebook likes, shares, comments, it's happening. And every minute everyone is tweeting and a lot of videos are all uploaded. So, now if you see this picture, it would have been, popular, so popular, and it was viral every year beginning. Data Never Sleeps is a company which is doing a survey, and every year beginning, they are just, I would say, sharing the data. This picture was popular in WhatsApp in January 2021. What they say, according to the statistics, YouTube, let us take YouTube, 500 hours of video is being uploaded in 1 minute. Can you imagine? 500 hours of video in 1 minute uploaded in YouTube. And 319 gains new users in Twitter. 319 users are joining in Twitter. I would say Facebook has 150,000 shares in 1 minute. LinkedIn has 69,000 plus job search in 1 minute. TikTok again has 2,700 posts. Let us come to Insta. 138,000, Insta posts are happening in 1 minute. Next is Amazon. Every minute they are making money. You can see in 1 minute Amazon is serving 6,659 orders in 1 minute. Can you imagine? And this is the quantum of messages that are being, exchanged in WhatsApp. And Facebook also, if you see, more than 1 lakh of uploads and things are happening. And Zoom, especially last year, 208,000 meetings are scheduled in 1 minute. So these are all the people who are the major contributors. Like Spotify, 28 audio tracks are being downloaded every minute. And Netflix, again you can see, more than 4 lakhs users are streaming live in Netflix. And we have seen about Instagram statistics. So these are the major contributors who are increasing the data. First is IoT, second is social media. We have seen. The other factors are these industries, whether it is banking or finance or media, education, healthcare, government, transportation, insurance, and retail. Some of the case studies we will see. Now, in the year 2012, IBM did a survey about how the data are being generated from various sources. So, they say in 2012, it was all transactional data. It could be a bank transaction, an inventory transaction, or online transaction, generally they are talking about. And then 73% was protocol data. 2012. Now, it is completely reversed. Sensor has taken up the top priority today. Even RFID, it is taking 41% and geodata 40%. Now, the entire graph has just reversed. The social media, earlier it was 43%. Now, I would say IoT is 88% and social media is 73%. That is the kind of revolution it has happened. If you see the big data statistics, Google is getting 3.5 billion searches every day. And WhatsApp is getting 65 billion messages every day. And Twitter, it is having 500,000 tweets every minute. Facebook, 4 petabytes of data. We have just seen what are petabytes. Petabytes of data are being generated. Now, one important thing, amazing thing you see, 500 hours of video in 1 minute uploaded in YouTube. We know that. If you want to download the content of YouTube, it will take 15 years for us to watch completely. So that means you can see the data slide, how it is happening. 15 years it will take as of now, the data which is available in YouTube to watch it. 6 to 7 hours of flight, when it is flying from one place to another place, it is generating 240 terabytes of data. And big data. Using big data, Netflix is saving $1 million customer retention. Because CRM, again, it is a major important aspect of escalating any business. So, through business analytics and through the suggestions and recommendations and sentiment analysis incorporated, the OTT apps like Netflix, it is generating $1 billion revenue. Now, 570 new websites are springing every minute. New websites, 570. 97% of the organizations are investing in big data and artificial intelligence. That was a prime reason for us to take this topic, big data. Why big data? Because it has a future. At least for a decade, we can see the big data will be available in the market, and the trends are continued, it is rather escalated because 97% of the organizations are investing. So data science is a booming industry. Data science with IoT, they are the major contributors. Poor quality data or the data maintenance, if it doesn't happen, it is creating a loss of $3.1 trillion losses in US economy. We can say, and we have seen about the internet data and social media data. If you see this, Amazon records $4,722 of sales, and each minute Amazon is minting money of $283,000 each minute in an hour. And then the average is $17 million. Average income in a day is $17 million. So no wonder why Amazon is number 1 in the world. Why Bezos is the richest person in the world. He says, we have to think 100 years backward and 100 years forward. He read the history of the entire world and the civilization and the living standard and the lifestyle of the people 100 years back. So he is able to think 100 years ahead. He says, even if it doesn't invest much or doesn't grow much, at least for 100 years, his business will sustain. That is what the growth of Amazon, right from an online book store. Now you can see it has more than 1 crore products. And it has a fulfillment center in almost every country, 50% of the countries. You could see that. So, 45% of the business businesses worldwide are running at least one of their big data workload in the cloud. We say cloud. We imagine something is storing in the cloud. Actually, it is not in the cloud. It is all stored in the data centers. So, to process the data, to store the data, and to access at a very fast speed, we are using big data. So, in 2020, 40 trillion GB of data, that is 40 zettabytes of data are being created. So, 90% of the data which is available in cloud are created in last 2 years. Last year, major contributors. We know that most of us have, I think 80% or 90% of the people, they started buying mobile phones. Earlier, we used to restrict our kids for mobile. Now, we got the mobile for them because they have to attend the classes. So, the revolution or the big jump in the business, I could say, all these LMS systems and e-learning portals, e-commerce portals, and then hardware industry, whether it is the industry which is manufacturing laptops or tablets or mobile phones, they all got at least 30 to 40% of surge in their business, we can say. So, it will take 181 million years. All these statistics are taken from techjury.net. 181 million years for us to download the content from internet. Earlier we said only from YouTube it will take 15 years. Now put together in the entire internet, if you see 181 million years it will take to download the data. So you can imagine how much data has been created in internet. Okay, so people and rest are all the rural people. Now, out of which 5.2 billion people, almost 66% of the people are using mobile phones, and 4.66 billion people are using internet, and 4.2 billion people are using social media. Almost 53%, I can say. So Facebook, the usage was more. It is the previous statistics. Now it would have been changed to Instagram, I feel so. So almost daily, 75% of the people are watching Facebook, Instagram, then Snapchat, and so on. Twitter, almost 45% people, and 50% of the people watching YouTube. So, having said all this, the data and the contribution, what is big data? So, the data available on internet and in companies are becoming larger, right? So, big data is originated from English-speaking world. We can say the industries and the organization, big data encompasses information from internal and external sources. It could be transactions, social media, enterprise content, sensors, and mobile devices. So, sensors are the major contributors of big data. So, as we have seen, cloud computing, sensors, mobile-to-mobile communication, social media, and the GPS or other location-based services. They're all contributing to big data. So, we can say the data which is very large, very complex, very difficult to process with the on-hand database systems. On-hand means the traditional database system, the structured database system, or the relational database system. You all would have heard about the revolution or the evolution of databases. Earlier we had flat files, the files which we were using in BASIC or Fortran or COBOL languages, and then the evolution came with DBMS, database management system, then DBase, then Clipper, all these database systems were used, then Oracle, then Ingres, then DB2, and then SQL Server. These are all the databases, right? Now, from those databases, it was all to semi-structured databases like XML databases, RDF databases. Now, we are into unstructured databases. Unstructured, why? We can't predict when the data flow will happen. We can't predict how much important it is. We cannot predict the volume of the data. So, they are all unstructured data. So, big data, it is handling basically the unstructured data. So, unstructured data cannot be handled by the traditional database applications. The traditional applications, as I said, it could be SQL servers or Oracle, or it could be any of the database technologies that Microsoft is using, right? Now, these are all the major characteristics of big data. Which data can be called as a big data? We are buying an ERP for our college maintenance. We have our student records and we have the attendance, we have mark list, we have result publications, we have placement statistics. Can we call that as a big data? That is my question. So if you want to call any data as big data, it should have all these characteristics. These are the 5 major characteristics that a big data possesses. First is volume. Volume means the size we are talking about. See, nowadays we have 44 zettabytes of data created. So then we can call, if the data is of high volume, we can call it as a big data. Second is variety. The data should be of not the same type. It should not be a structured one. It can be a picture, it can be an audio file, it can be a video file, or it could be some reviews, some comments, anything. It can be multiple variety of data. And logs that are generated, or the sensors that are continuously bombarding the data, sensing the data, any data it could be, but with different variety. The third is the velocity. Here, velocity, I mean the speed at which comes in. For example, if Prime Minister tweets something, immediately you can see the flood happens like anything. Or a Hollywood star or a Bollywood star, if he posts something in Insta, see the comments, the reviews, the shares that happens. So it doesn't have a constant time or the speed. It depends on the people who are posting on the social media site. So suddenly, if any controversial thing happens or any things that are trending, you can see the people are following more. Spotify, for example, it is a podcast app, musical app. So a new song is being released, a new album is released. Immediately what happens? Entire world, the people, they just have a look at that, and within a minute or they provide a statistics. Within 30 minutes, number of people downloaded, number of people shared, number of people liked, reviews. So the speed we cannot, the velocity we cannot predict. And the fourth one is value. All this data are having a lot of business value. Once you have the people who have registered with your application, with them you can do the business. So every data, it is creating some commercial values. And then veracity. If this data flood happens while streaming, there may be chances that we lose the data. So the missing data, in between the data would be missing or it would be inconsistent. Okay. In that case, we call it as a veracity. So if your data is having all these characteristics, then we can call it as a big data. Hope I'm audible and clear. Any questions, anything, any interaction? Shall I continue?
Ma'am, you are audible, and if participants have any queries, they can put to you on your chat box, ma'am. They cannot unmute themselves.
Okay,
Yes,
so the audio rights are not given to the participants, right? Okay. Okay. So
Yes,
then
ma'am.
we will take up the questions. Okay. Is it going good? Any comments, ma'am?
Yes, ma'am. Absolutely. Absolutely, ma'am.
Okay, fine. Thank you.
It was really informative, ma'am.
Thank you. Because I feel I'm just looking at the monitor and I'm talking, so I would like to, get the feedback also in between. Thank you.
Yes, ma'am.
So, we just talked about the volume. So, as we know, by 2020, we have 44. Like last year, we had 44 trillion gigabytes of data. As the statistics rightly said, you see 2 years ago, how much the data? It was only 22 zettabytes or trillion bytes of data. Now you see from 22 it has become 44. So how? Because of the advent of, I would say all smart technologies. Yeah. So from 2017 or 18, somewhere around 22 zettabytes, now it is 44 zettabytes of data. So almost doubled. Then variety. As I talked about, structured, semi-structured and unstructured. If you have a data organized properly in a tabular format, normally the student database or a library database in the college or the financial transactions that we are doing, maybe a salary or an income and expenditure statement, everything has a fixed format. When we are able to represent it in a fixed format, they're all structured data. When we are creating our own formats, then the data like XML, JSON, CSV. CSV is, I think we all know, comma separated value files, and TSV, tab separated value files, emails. All this data are semi-structured data, so partially structured. And unstructured data, the logs that are created. For example, if you are connected to a Wi-Fi network of your college, the college server can produce the logs that what are the frequent websites you watched, how much data you downloaded, what was the internet speed that was available to you, okay, and how much you are utilizing, which pages you lastly browsed. Entire log will be available in the server. That is what log data. Right? Audio data, video data, image data, they are all unstructured data. So this variety of big data has been able to handle. The third is the velocity. As I talked about, the speed at which the data comes. We have just now seen in 1 minute at an alarming rate how the data are being created. Whether it is YouTube or Zoom or Netflix or any other OTT apps like Amazon Prime, you can take it, or Sony Live, we can take it, or Z, we can take it. Everywhere nowadays, you see, all the movies are also released on the OTT apps. So the data is tremendously improving, the speed at which it comes. Next is this data. From this data, we can draw useful conclusions. We can interpret the data. We can create a lot of commercial value. From one data, the other one can emerge. Like we get a lot of promotional calls, we get emails, sometimes we respond to it, and then it is leading to a business, it is leading to a network, it is leading to some business investments, whatever it is. So everybody are getting some benefit out of this data. It is creating some business. Then the veracity. Once the data is streamed live, we tend to lose in between some, distortion that happens, in between some break happens in the internet, yeah, and due to which the poor network, yeah, the data is becoming uncertain or inconsistent. See, here it is missing. If it is a tabular data, we cannot find any missing value. Whereas if it is a internet data, see, this is missing. And here, this data is being missing. Wherever we have put question mark, this data are being missing. So, such missing data also, big data is able to handle. I think I talked about this evolution, like we had a flat file using basic Fortran, COBOL, we created, and then information management system took place, mainframe computers came, information data system also took place, then Oracle, Ingress and DB2 in the 1980s, I would say, then 1990s, SQL Server, MySQL, ERP, all this becomes so popular, then XML, semantic webs and multidimensional data. From 2000, these are all the other databases which are becoming so popular. They are called as NoSQL database. NoSQL means we are not saying no to SQL, not only SQL. So SQL means a structured query language. If we have a relational database like Oracle, we can write a query, structured query, to retrieve the data from Oracle or any other relational databases. To retrieve the data from these databases, we use the language called SQL, query language. But now we are using key value pair database, document store database, column oriented database, graph based database. We are representing the data, the connectivity. Simple example I'll tell you. In Facebook, we have friends and friends. So how the recommendation comes, your friend like that, do you want to, he has given a request, your friend, he can be your friend. So sometimes voluntarily they give recommendation. The people who wants to send you a request, you are getting friend request. Sometimes Facebook automatically suggests you, add to your network or add this friend. How it is suggesting? It is checking the link of your friend to friend, friend of friend. From there it is giving you. So this relationship, one person from India connected to Australia, connected to California, okay, connected to Sri Lanka or Afghanistan, how they are all connected, where we have in different geographical locations, the friend of friends. So this network, it has been, depicted properly using graph-based. So these are all the NoSQL databases. JSON, YAML. YAML is yet another markup language, RDF, Resource Description Framework. It talks about the entire history of internet. If you launch a website, it will tell you when did you launch, who are the authors, how many people have seen it, what is the size of the entire website, how many pages, frequently used pages, when it was created, all the history of the particular website. It is being represented using RDF. And we have one more type called JSON and BSON. BSON is again a binary, object, binary network, I think. And then we have other databases like Cassandra or Couch databases. Okay. These are all the different NoSQL databases that is being supported by big data. Binary object notation. Now, as we have seen, ERP is contributing, CRM is contributing, web is contributing, everybody are contributing the big data. So, here, if you see, major contribution, it is happening from the spatial data, from the sensor data, you can have, and from RFID data, it is happening, and the external demography data, multimedia data, like hardware, audio data, video data, everything. Yeah. Okay. As we have seen here, that is Java script object notation, JSON we talked about, and JSON is again binary script object notation databases. These are all NoSQL database types. These are the new terms, the NoSQL data types which are presently handled by big data. You see here, audio data, video, images, all these are major contributors. Social interaction, social networking, speech to text, MMS. Okay. Now, can you see what is it? This is another, I can say, a feature of big data. We see that it is just like a tree. The data visualization, whether we are drawing a graph using Excel or any other tool, it has a limitation. Okay, when the data grows, say I have 90,000 data, how to visualize it? So we need some scatter plots, some box plots, some histograms, right? And a visualization like this. If I zoom it, I can show you. These are all the names of a particular phylogenesis organism of a tree. For a tree has multiple categories, multiple phylogenesis organisms. See, it can be of type fungi, it can be of type bacteria, it can be type of animalia. So, a category of a tree and its phylogenesis. So, there are 90, how much it is represented here, you can say, it is more than 90,000 types, 93,891 species are represented in this. Can you imagine? 93,891 types of phylogenesis, and the color also it is depicting. One is of animal, one is of plant, one is of bacteria, one is of fungi, one is of acacia, and so on. So 93,000 data. It has been depicted into a single tree. This is the visualization that the data, I can say, the big data is contributing to. Data visualization is the major part. And other opportunities, if you see, it is cost effective. It is used in automated car, healthcare industries, and it can also be used for quickly analyzing the information. Now, the case study I said, we will discuss about IoT, a case study of big data. So, this is the case study. IBM in 2012, we discussed that they started analyzing about who are the major contributors of data. That time transactions were more, whereas now it has changed. We have seen that graph. What they did in one particular city in US, they've taken and they were observing the power consumption. Earlier, they had a normal meter where the power consumptions are being showed every month a reading, and every month only once the reading was taken and the people used to pay the electricity bill. Later, IBM installed a smart meter. Smart meter, the data was collected every 15 minutes. what is the power consumption, which area, whether it is rural or urban, or it is domestic or it is industrial, everything. Every 15 minutes, the data consumption, the power consumption, they started monitoring. Then they were managing the large volume and velocity of information generated in a short interval, because every 15 minutes entire city's data through a smart meter they started reading the data. So 96 million reads per day for every million meters. That is, for 1 lakh meters, 96, because in a day if you see 96 times it was reading the data. So for 1 lakh, that is 1 million meter, 96 million reads were happening. So it is obviously a big data. So what they did based on this data, by reading this power consumption through smart meter, what they did. So IBM offered an integrated suite of products to enable the IT to leverage the big data in the ways that it can contribute. So in smart meter, it has installed the sensors used to sense the power consumption, read, and it will connect it with the server and it generates the data. So these are all the steps involved in solving the problem. So first IBM installed a smart meter, and every 15 minutes it was observing the monitoring. Then it started monitoring the power grid from where the electricity is being distributed. And then it started optimizing the unit commitment, and it started optimizing the energy. It started forecasting and scheduling the loads also. How it was possible? It was possible because of the data it collected, it mined the data, it analyzed the data. So the data first it was stored in the warehouse. From data warehouse, it started mining the data, it started analyzing the data, and it produces all the reports. It was outsourced to a company called Anchor. So Anchor is a electric delivery company which is using your IBM smart meter device. What they did, they followed the procedure of instrumentation, interconnection, and intelligence. So the smart electricity meter accurately measures the electricity usage. So instrument, interconnect, unprecedented access. Like we know, normally the people, some of them, they tend to cheat the meters also. So such unprecedented access, or they use for the official industrial purpose, but they would have got it under the domestic connection. So such unprecedented access detailed information also they got to know. Then intelligent. The consumers, they were monitored and controlled their electricity. So intelligent, we could say. Instrument, interconnection, and intelligent. It could all happen because Anchor company, it started using the IBM smart meter, and IBM started collecting the data, and then finally you see the benefit. The customers in the Anchor service territory showed last year during the company's biggest energy saver contest, and that by using the information of advanced meters. So energy saver, why it could save? Because unprecedented connections it could absorb, and where the usage is heavier, there it was trying to balance the usage, and then it was able to shed the load properly, the load balancing it could do. So the billing also, then it has been reduced. We can see that the users have reduced the electricity usage, and they could save 25% of the amount, minimum 25% of the amount they could save it. So this is the kind of advantage that we get it once we use our IoT devices embedded with big data, where we can save the cost. The other applications when we see, we can use it in banking, communication, healthcare, education, manufacturing industries, and government, insurance, retail, transportation, energy, and utilities. Okay, it's all fine. We have a lot of data coming in, and what are the problems we are getting with big data? These were the major problems. So we are collecting the data. 96 million reads are happening every day. Where to store all this data? This picture shows it all. We have a small almirah where we are trying to push a huge animal into that. The same way, the data generated in the past 2 years, it is 44 zettabytes, okay? And Every second a person is generating 1.7 megabytes of data. Where to store the data? So the major first problem was the storage. Second problem, this data are of different types. We know that it is of structured, semi-structured and unstructured. How to process this data? If it is of same type, it is easy. If it is of multiple types, how are we going to process? Because it may be of XML data, it can be of multimedia data, it can be of RDBMS data. How are we going to process this data? And the third major problem was how fast we can process. One is the size, and second is the type, and third is the speed. How can we improve the speed? Because the hard disk capacity versus the disk transfer. Does the hardware support the speed at which it can be accessed? Because we have a master and we have multiple slaves. So bringing the huge amount of data, it becomes a bottleneckness. How are we going to process? So these three were the major problems concerned with big data. So how these problems were solved? The one solution for solving this problem was Hadoop framework. It allows us to store the large data set in a distributed fashion. So the first problem got resolved with the help of Hadoop architecture. Hadoop is nothing but a framework which we need to install it in the server machine. Automatically, Hadoop provides the file system which is called as HDFS. HDFS is Hadoop file system. And then map reducing technology it is using. For processing, it uses map reducing. So two of our major problems are solved by installing Hadoop. So Hadoop, it uses open source framework. Okay, it is all coming under Apache Software Framework, ASF, because it is all open source. It's completely free. It is written in Java. And currently, which are the companies using Google, Facebook, LinkedIn, Yahoo, Twitter? Everybody are using Hadoop architecture. Because Hadoop has a huge storage capacity, we can create data centers, and in data centers, in multiple racks, we can store the data. So Hadoop is providing such architecture to store the data, and using the MapReduce technology, we could process the data as well. It's a distributed computing. Why distributed? Because we want to store the data in multiple locations. In one location, at least we call it as replication. In one place, if your data is failed, we should have some backup somewhere we can retrieve the data. So for that, normally, in files also we take multiple backup. And our files are important. One is in our hard disk. Second, you will upload it in your mail. Or third, you can take it in your pen drive or in hard disk. At least 2-3 copies we have. That is our backup. Correct? Similarly, if the files stored in the data center, we tend to lose those files. What will happen? So, in remote locations, different geographical locations, the data are being stored. Storing one time also a problem. You imagine at least a server maybe in Australia or one server maybe in North America. Why? Because if the Australia server downs or the data is unable to retrieve, we can take it from North America because this data is having important business value. So the computation speed is increased because of the parallel architecture. So how to process this big data at a reasonable cost and time? As we know, as the size grows, the hardware cost will be more, the accessible time will be more, and the cost will be more. So all these things are handled by the Hadoop distribution file system. We call it as HDFS. HDFS, it creates the abstraction. It has a master node and it has a slave node. The master node, it is called as name node. It will have the metadata. Metadata means data about data. So if I have 512 GB of data, it will equally divide into 128 MB each, the block size. It will store the data in multiple blocks. It will divide the data in multiple blocks. So every slave, it will have this data. So this is slave 1, slave 2, slave 3. Every slave, it has the data. And this is one slave, this is another slave, this is another slave. The data is being divided into blocks. Every block is stored like this. Example, as I said, 512 MB of data is divided into 128 MB each, and every block it is stored. See, this data it is stored here, and this one it is stored here. The color identification you can see. So this is the way it is distributing. It is not available in one location. Once it is distributed, the speed will be more. Even for IBM, the case study what we have seen, smart meter, so locality wise it would have distributed. Though we are taking for a city, it would have regionally taken the data from multiple locations and stored differently in a distributed way. You see, this is the data rack in the data centers. What we feel, big data we are storing in OneDrive, we store in SkyDrive, it will be stored in some cloud, whereas actually it is all stored in data centers like this. Every data center has multiple racks. In every rack, the data is being stored in multiple blocks. So you have a chassis, you have a rack, and you have a site. The entire thing is called as a site. And you have the node. The node will have the information about which data is stored what and where. What is the size of the data? Okay, if it is a 512 MB data, first 128 MB is stored in which rack, second 128 MB is stored in which rack. That information is available in the name node. You can see this is the normal size of a data center. We all feel we don't carry CDs, we don't carry hard disks, we are good, we are saving no e-wastage, but you see the e-wastage. This is how a data center looks. Everywhere there are multiple racks, units, and every rack is having multiple clusters, and every cluster is having multiple data. So this data from this cluster would be connected to another data in remote location, because I said minimum 2 replications, minimum. It is happening. That means if I have a Gmail data, my Gmail data is stored in 2 different locations. Already we know we are using some 15 GB space. That 15 GB is replicated twice. So 45 GB of information is stored. So, dear friends, I would like to appeal to you, anything you find which is not important, not of use, please tend to clear. Please tend to purge all those things. Clear your bins and clear your data. So, we are contributing to, otherwise, we are tremendously contributing to e-waste. Every data center, cost is incurred for all this hardware maintenance. Yeah. Now, the second problem, first problem of storage, it is being solved and processing is being solved with the help of HDFS. The second important problem is storing the unstructured data. Unstructured, we have seen multimedia data. So, such multimedia data are being stored in HDFS. Write once, read many times. So, frequently if you want to update, big data is not a technology for that, because I said it requires huge infrastructure and different geographical locations. So if it updates in one place, again it has to be updated in multiple locations. So frequently updated data, we need not store it in big data. Okay. And only once you are writing, but many times you can retrieve. Called that worm. Write once, read many times. Such data can be used in HDFS. So the second problem is solved. First problem was storage. Using Hadoop it is solved. The second problem is variety of data that is being stored in HDFS. And the third problem is the speed. How to improve the processing speed? If you have everything in one location, which will take 4 hours for you to process, if you have distributed with 4 different clusters, it will take only 1 hour for us to process. 1 hour each, so 4 clusters. So 4 hours of processing is being reduced to 1 hour. So because of the data distribution and parallel access, the time taken for processing is also being improved. So Hadoop, it is using a technology called MapReduce for processing the data. First, it will map it with different locations. It will map the data in different locations. Then it will reduce it, and finally it will give you the results. So, in a nutshell, if you see, it is doing all operations. like the functions it is incorporating, indexing, classification, analytics, modeling, programming. It can generate the reports like summary, classification, everything it can do. How it is doing? With the help of Hadoop framework. It has installed various components of Hadoop like HDFS, Pig, Hive, HBase. Through that it is processing. I'll give you an example. Normally, whenever we want to count the votes in the election, we have different locations where the votes are being counted. So, earlier days, what they used to do, they collect all the votes from different booths, they bring it to the centralized location, and here they count it. But now, they are using distributed fashion. I can say, in one particular territory or one particular area, all those booths data are brought, and here it is counted, and only the results are being given to the centralized location, so that the data movement is avoided and the speed is increased. Instead of moving the data, only the logic is being set, and every slave, every location, it is processing the data, only the results are updated to the master. That is what distribution or parallel processing. So, in different regions, the booths are available for counting the data, only the results are being sent to the master. But earlier how it used to happen, only one center, all booths will collect the data and send it to the master. So the traffic, the time, and the centralized location, the speed, everything was less. But now, we can say moving the data is very costly, so we are moving the processing to the data. So it will tell how to count which are all the parties and how to calculate the percentage. Only the processing logic the master gives to the slave. Slave is processing, it is supplying only the results are being given to the master. So this is the way the architecture looks like. You can see the Hadoop system. We need a normal server class machine. So if we have a Linux operating system, above that we have to install the Java virtual machine. And over that we can install Hadoop. Once we install Hadoop architecture, we get the Hadoop distributed file system and we get the Hadoop data processing. That is MapReduce, the logic. See, the programming, or I can say the algorithms or the processing logic is called as MapReduce. Many of us, we know divide and conquer. The same technologies are MapReduce. If the problem is very big, you divide it into sub-problems and solve it in the sub-problem, then you integrate it into the main problem. The same concept is being incorporated in MapReduce. Then, data storage. Hadoop, just now we have seen HDFS, it is storing semi-structured, unstructured and structured data, and it is processing. Now, these are all the access framework. For example, the applications like Yahoo or Facebook, they are all accessing the data which is available in the HDFS through the network. And we need to have the backward compatibility. That means earlier I had my relational database. From Oracle, I want to bring it to big data. From XML, I want to convert into big data. Or from my warehouse, the data which is in the enterprise data warehouse, that data can be brought to big data. So, how it is supporting? The previous technology data can be stored in big data using this orchestration framework. So, these are all the frameworks, HBase, Chukwa, Flume, Zookeeper. These are all the framework that will support the migration process or data integration process. Orchestration is nothing but integration. Data available in various sources, they are all integrated into Hadoop architecture. And then, once it is available in this HDFS, we can generate a lot of business intelligence applications, analytics, queries, reporting, statistics, everything we can generate it. We can have multiple backup, as I said, minimum 2 backup. We can deploy it, we can impose the security aspect, and then we can manage the data well. This is the architecture of Hadoop. Any questions? Any doubts? Is it going good? None? May I get a feedback?
Yes, ma'am. Yes, ma'am. It is going good, and you are audible and clearly, properly audible. If participants, meanwhile, if you have any doubts, please put it in the chat box so that ma'am could see and answer your questions in between the session.
Okay. Any questions in the chat box, ma'am?
As of now, ma'am, there.
Okay.
If they have sent you in personal, so on that you can see on your screen, ma'am.
Yeah. Fine. We will continue.
Yes, ma'am.
Okay. So I talked about this first row we will take. Sorry, second row. This pig, hive, scoop, avro. What are they? They are all the data access framework. So Yahoo is using the pig framework. Hive is used by Facebook, and Scoop is used. See, this is the application used to convert your relational database into Hadoop. And Avro, again, a row-oriented database. Data can be of any type, any structure. Everything can be converted. The Facebook data can be brought to big data using Hive. The Yahoo Mail data or Yahoo Chat data, Yahoo Messenger data, Yahoo user's profile that could be brought to Hadoop using PIG framework. So any data which is of relational data like Oracle data or SQL Server data, you want to bring it to Hadoop, you can use it through Scoop. So this is all for data integration purpose, data access purpose. And then this components, if we see, HBase, Chukwa, Flume, Zookeeper, they're all the orchestration tools. I think I've shown you here, HBase, Chukwa, Flume, Zookeeper, orchestration tools. They are for integrating the data, for monitoring the data, for collecting the data, and for distributing and configuring the data and synchronizing the data. So that is the purpose of orchestration. Now, let us come back to IoT application. So, as of now, just to put it in a nutshell, we have seen some of the important definitions of IoT, and then we have seen how IoT is contributing to big data. Then we have seen how the data flood is happening. In a minute, how many hours of video are uploaded by YouTube, how many users in Facebook, and how many meetings in Zoom, all that we have seen. How the data flood is increasing day by day. We have seen that. And then how IoT or social media is contributing to big data, we have seen. And then we have also seen 97% of the companies are investing in big data. And then we have seen 5 characteristics of big data, that is the volume, the variety, the veracity, and I would say the velocity of the data and value. These are all the 5 important V's of big data we have seen. And then there are 3 major problems that the big data was facing. One is the storage. Second is storing different types of data, that is unstructured, semi-structured data. And the third one is the speed at which the data is going to access. So how it is being solved? The storage is being solved with the help of Hadoop architecture. And then the different types of data, the processing is being solved with the help of HDFS, that is Hadoop distributed file system. And then the speed is improved, the processing speed, because it is using MapReduce, that is divide and conquer type algorithm, and it is using parallel and distributed database. And then we have seen how the traditional or old data can be brought back to Hadoop architecture. So this is what we have seen, a quick recap I have done. Now let us see in the applications of IoT. The first application is in the consumer side, like smart homes or optimizing the energy usage. Even now we have automatically using a mobile application installed, all your sensors are sensing whether it is your smoke detectors happening, or a washing machine to be controlled, or a microwave to be controlled, or a TV to be controlled. We are using smart control applications. Consumer perspective, IoT is being used. And then retail sectors we are using. Then medical sector we are using. Remote resource allocation, threat analysis, troop monitoring. And then in industrial, smart meters, warehouse technologies. and climate controls, then automotive industry, automatic parking, the traffic flow, environmental area we have seen, how the resource management, weather prediction, rainfall prediction, climate prediction, we can save the crops, the agricultural, how it is contributing, we have seen crop management and soil analysis. Everywhere IoT is playing a major role. Now, the applications of IoT. One of the best example is the shopping cart. Especially in US, it is automized now. Very soon we are going to get it in India. The first step is when you're shopping in the market, the goods will introduce themselves. So these are all the shelves. In the shelves, the goods will introduce themselves. Like, I'm a vegetable, you come and pick me up. I've been grown in this place, and this is all my nutrition values. All that you will get to know. Second, when entering the doors, the scanners will identify the tags on the clothing. So whatever dress you are wearing on that, it will identify your face detection, and then the tags will be placed. And third, when moving the goods, the reader will tell the staff to put a new one. Okay. So while reading the tags, the staff, as soon as they pick up it, the tag which is connected with you and the tag which is available on the goods, both will be matched. So the billing will be automatically generated. And then when you are paying for the goods, the microchip of the credit card will communicate with the checkout reader, automatically the chip. So the credit card bill, from your credit card, the money will be detected automatically.
It's not audible again.
It's not audible, sir.
It's not audible. It's not audible, sir. We'll share this link to participants. Yeah, participants can.
Fine, sir. That is fine. That is fine. So the video was showing that, without you need not carry anything directly. They can walk in. They can pick up the items. Since the tag is already installed in both the items, and then the face recognition or maybe the RFID tag that you have it with you, both will be linked, and automatically the bills are processed and it will be added to your credit card account. This is Amazon Go, which is already implemented in US. So we were talking about that.
Yes, madam. Now your presenter can share. Yes.
Yes, sir. Is my presentation visible?
Yes, yes.
Yeah. So that was one of the important applications I talked about. So it is all the shopping thing. Whatever we discussed here step by step, it is all automized and already implemented. You can see that link. I've shared it in the chat box. And the second one, Second one is the application of IoT in the fleet management. See, there are a lot of consignments, especially in the logistics industry. It is moving from one country to another country, and we want to keep a track of it. It may be of worth rupees crores or something, very valuable items it could be, or sometimes it could be of more confidential loads that are being transported from one place to another place. So we want to see how the fleet management is happening. So there will be a sensor installed, right? And the GPS locator that will tell us where it has moved and where it was supposed to go, where it is, reached now, what are the hurdles it is facing in between. So the locations, it has the attributes of the vehicle metrics, the driver behavior, and hours and miles driven. How many hours he has driven and where the vehicle is located. So this information automatically it produces. The sensors incorporated, it produces the time sensors, the geolocation sensors, we can say, and then the driver geo ID of the driver, it can be tracked with the vehicle. And then it is transmitting the information, it is processed in the data centers, and then we are getting the report. We can see how soon it has reached, whether it was supposed to reach, and how much time it took, and where the traffic was more, or whatever it is. So the fleet management. So 200 plus variables are used in each truck. So that is another important application of IoT, and it is creating big data also. And the third one, if you observe this picture, it is all about the automation that has happened in a hospital. You see, right from the registration part where he wants to visualize what are the diagnosis tests he is undergoing, and then, the people who are waiting to see, and the person who is admitted in the hospital, he will be given a tag. So that tag will have the information about the complete history of that person, like what he is allergic to, what are the complications he has, who are the contact people, and how many times he was admitted, and which hospital earlier he was, what sort of medicines and the treatments were given to him, the entire history. And then he will have a small bell and a wearable device. Just if he press it will be connected to a particular nurse. The nurse will come and the attendant will come. Like that, there are multiple buttons, or it can be an application through mobile, which will be automized in the entire hospital. It is all already implemented. So wearable devices are used, patient records are monitored, automation in elevators, door locking also in the hospital. Then nurses and patients IoT alerts are happening. Then the medication is also automatically dispensed. Like how we are getting ATM, the cash, the same way medication. If we show the proper prescription signed by the doctor, the medicines will be automatically dispensed. The health tags, the tags which has the patient history, and then the location of the patient, and it is for managing the data staffing. So this is another major application of IoT where healthcare industry are using. And then the brilliant one is all about the smart home. The lights, the speakers, the window shades, the laptops, the TVs, the tablets, everything is connected with internet. So it has a thermostat for controlling the temperature. It has a smoke alarm which will tell you when it goes to beyond a limit, and it has a pool and spa. There also the sensors are used for water levels. And then the exterior lighting, even you all would have experienced it. We have Alexa lamps, Alexa lights. They control, the luminosity or the power of the light. You can say reduce the light or increase the illumination of the light. All that we can do it in a smart home, completely controlled by IoT. This is again a major contribution of IoT, I would say. And this is again leading to big data. And other applications, if you see, it is air pollution, landslide prevention, earthquake detection, water leakages, smart grid, structural health. Structural health means the structure of a building. You see now bamboo structures are the goods for inventory, and the payment, NFC payment, smart parking, tank level, the water level, and waste management, smart roads, river floods, all these places we are using the IoT. So the second video, it will tell you about how we have automized the entire house. How Alexa or maybe we can use Siri to plan our day, right from waking up till you go to the bed. all your meetings can be scheduled, all your refrigerator systems can be automized, all the sensors that are used in your kitchen, in the microwave, how it is used, and how to, once you go to the office also, using that app, you can control some of the devices at your home. So that's a beautiful video. You can have a look at it later. So the session outcome, I would say, we started with Internet of Things, evolution of big data. Then we learned about the major characteristics, 5 V's of big data. Then the case study of IBM. And then what are the problems and how it has been solved through Hadoop. And these are all the important applications of IoT. That's what we have seen. I'm so sorry for the technical glitches that have happened. Unable to share the video. We will try to improve it better next time. And any questions, I would be happy to see the chat box. These are my contact numbers. Any questions from the delegate side?
Thank you so much, ma'am. That was a really wonderful session. And I request participants to kindly put your queries and questions in the chat box. It could be as simple as possible. Please feel free to put your queries in the chat box.
Any feedback also you can share so that I'll try to improve next time. I hope I could do the justice for the topic. It has been allotted to me. Big data.
You were excellent, ma'am, and data and analytics and the information you have provided, most of the topics we have seen for the first time, and got to know a lot of things, got to know a lot of new things actually, and that was really helpful, and I suppose it was really helpful for the participants too.
Thank you. Thank you for the feedback. Any questions from the audience side?
Ma'am, on my side, I couldn't see any questions. Ma'am, you can check on your chat box, ma'am, on your personal chat box, ma'am.
Yeah. Stop sharing. I couldn't see any questions then.
So I guess there would not be any doubt.
It's fine.
We can wrap up the session, ma'am. Thank you so much once again, ma'am. Thank you so much for your precious time to share with us.
Thank you so much for giving me this opportunity. And once again, kindly, I apologize for the glitches that I could face. And I thank Dr. Lakshman, who was, initiating this particular workshop, this faculty development program, coordinated with me and the organizer of the particular program, this FPT, on behalf of IEEE. And also thank all the management for organizing this. What is a block and
there is one question.
Yeah, yes, sir.
There is one question. This block and block scanner in HDFS.
Yes. Yeah. Block means if you have a huge data is divided into multiple sizes. Like earlier in Hadoop version 1, it was 64 MB. Now we have 128 MB. That is the block size. However big the data is, it will be divided into 128 MB of each block, and that will be stored in HDFS. So the scanner here, name node is the scanner, which will have the information about which block is stored in which particular rack. If you remember, in the rack, there are multiple clusters. So in one rack, there are multiple commodity hardware, we call it. Commodity hardware is normal computer which is going and which is having a hard disk, RAM, and so on. So which rack and which computer that particular block is being stored, that is given in the name node. So the default size, as I said, entire data is divided into 128 MB blocks. So the scanner, it will, as I said, it will check the block which is close to the particular rack, that it will fetch it first. Okay, and in one rack, if there are multiple blocks stored, okay, the rack which is close to the particular cluster, there it will be stored, the data, and the name of the block to fetch. Okay, and it will identify which data node has what block. That is the purpose of the scanner. Okay, and it can be in multiple locations. There is a rack algorithm. Okay, how to store it. In one rack, there can be 2 replicas. But the third replica will be definitely in a different geographical location. Okay, so the name node will identify which block is located from which data node it will fetch, and it will give it to the client. Okay, so that is block scanner. Scanner's purpose is basically to identify which is the correct node and which is the corrupted node. The corrupted, if it is there, then it will verify from another replica. If it is the correct node, it will fetch and it will give it to the client. That is the scanner. The scanner job, it will calculate the data corruption. And the correct data, it will locate it from the replica, it will make it available to the client.
Ma'am, there is a connecting question to the same, the previous question.
Yeah.
Is it possible, instead of using 128 MB block, can we use 256 MB block?
No, as of now, the present Hadoop system, it supports only 128 MB block. Once the version is getting upgraded, then probably it may be, because the map reduce techniques and all algorithms are able to read only 128 MB as of now. We cannot increase the block size on our own unless and until the framework supports. The framework presently supports 128 MB.
Okay, ma'am. Thank you, ma'am.
Thank you.
I hope there are no more queries. So we can wrap up the session. Lakshman, sir, we can end the session now, right?
Yes.
One more question. What is inter-cluster copying? So inter-cluster, I said in one rack there are multiple clusters. Okay, so in one rack, 2 replicas are available. So copying from one cluster to another cluster in the same rack, it is called as inter-cluster copying. First it will be updated in the first cluster of the rack, then the same will be updated in the next cluster. So clusters are in a single rack. If it is available, copying from one cluster to another cluster, we call it as intercluster. As I said, maximum 2 replicas are available in one rack. Okay, so the cluster which is very close to your name node, that will be copied first. From there, the content will be copied to another cluster. That is intercluster copying. Copying from the one cluster to another cluster from the same rack. It is called as intercluster copying.
Thank you, ma'am. So, participants and everyone, we have come to an end of the session. Thank you so much, ma'am. Thank you so much, Dr. Lakshman Thapre, sir. Thank you, Dr. Nikhil Zerware, sir, and all the core committee of IEEE and GSRC for their constant support. And I see everyone tomorrow at 10 a.m. for the next session on the IEEE. So till then, bye-bye. Take care, everyone. Thank you so much.
Dear students, and one thing I would just like to say, and it is audible?
Yes, sir, you are audible.
Yes, yes. So we are actually sharing one feedback to all of you for improvement and better next time to the session. So we need your help. You can follow that feedback, which is going to soon you having it on your mail IDs. So this is for the today's session. That thank you for joining this session. Thank you so much, ma'am, for taking the extra effort. Yeah. Thank you so much from JSW College of Engineering, and thank you Purmai for a nice coordination.
Thank you, sir, always.
Thank you all.
Someone is asking, does Node also keep information of copies as well?
No, Node will have the metadata. Node will have the information about which data is stored where. It will not have the copies of data. Only the data node will have the copies. Name node will not have that. We have two nodes we have seen. One is name node, the other one is data node. So name node will have the information of which data is stored in which location, what is the size, and who is the author, all that. Only data node will have the original data.
Okay. Thank you so much, ma'am.
Yeah.
Thank you so much.
Welcome, sir. Welcome, sir. Thank you. Thank you for the opportunity and patient hearing.
Can you share your PPT, madam, for to share with the participants?
Yeah, I'll mail you, sir.
Yeah. Okay. Thank you, ma'am.
Thank you. Thank you.
Okay, dear participants, tomorrow we'll meet at 10 a.m.